Welcome to springlib.
So in this question, we have two waves of equal amplitude and frequency, but with a phase difference. So they have equal amplitude and frequency, but I will put an extra phase difference to D2. And now we need to use trigonometric identity that sine theta 1 plus sine theta 2 equals, we will use the identity of sine theta 1 plus sine theta 2 is 2 times sine half of theta 1 plus theta 2 cosine half of theta 1 minus theta 2. So I want to use this property to show that D can be D, which is like the superposition of D1 and D2, can be represented as one large sine function instead of two sine functions. So in order to do that, what we will be doing is we will have D equals D1 plus D2. And that is, they both have amplitude A, which I will simplify. So it becomes sine of kx minus omega t plus sine of kx minus omega t plus phi equals A times, so let's try to follow what the book tells us. So it becomes 2A sine half of the sum of this, which is kx minus omega t plus half of phi. And cosine, I subtract them, so it becomes cosine half of phi. Okay, and that seems to be what the question wants from us. So really what we need to do is just to plug in D1 and D2 expression to the identity as given to us in the question. Okay, so that is proved. And part B asks us, this is part A, what part B says is, what is the amplitude of the resultant wave? And is this wave purely sinusoidal or not? It is, we look at the amplitude of this. This looks like this is the amplitude. So the amplitude is 2A cosine phi over 2. And we look at this is indeed a constant because phi is a constant. So 2A cosine phi over 2 is just as a number. It does not change with respect to location and time. So it is purely sinusoidal. And let's look at part C. Part C asks, show that constructive interference occurs if phi equals 0, 2 pi, 4 pi, and so on. And destructive occurs if it's pi, 3 pi, 5 pi, etc. So that is because with different phi, we have different amplitude. So if phi equals 0, 2 pi, 4 pi, etc., if we draw, this is a function of cosine phi, 0, pi, this is 2 pi, this is pi, 2 pi, 3 pi, 4 pi, etc. We can see that at 0 and 2 pi and 4 pi, at these places where phi equals 0, 2 pi, 4 pi, half of phi equals pi, equals 0, pi, 2 pi, etc. So half of pi is integer numbers of pi. And when we have integer amount of pi as pi, 2 pi, 3 pi, 4 pi, when we have these sort of things, cosine phi over 2 is either 1 or -1. But what happens is that its magnitude is 1. It has the maximum magnitude possible. So that is why it's constructive. What about when phi equals 0 equals pi, 3 pi, 5 pi, etc.? In these cases, phi over 2 are half integer numbers of pi. Half integer numbers of pi. And the result is that if we look at half integer, it's here. This is half of pi, this is 1.5 pi. This is 2.5 times pi, 3.5 times pi. So the half integer numbers of pi are at places where cosine pi over 2 equals 0. So the amplitude of the wave is always 0. That's why it will cause destructive interference. The last one says, describe the resultant wave by equation and in words if phi equals pi over 2. So first let's do it by equation. By equation, d equals 2a cosine pi. When phi equals pi over 2, cosine phi over 2 is cosine pi over 4, which is cosine 45 degree, which is square root 2 over 2. So this actually becomes square root 2 times a times sine of kx minus omega t plus pi over 4. So it has an amplitude of square root 2 times a, and it's traveling in the x direction because we have minus omega t, and this wave is shifted to the left by pi over 4, and that corresponds to 1/8 of a cycle.